Hello, David here, and welcome to a tutorial on process modeling transport filters in Visual Components. When following any tutorial, check the lesson in the Visual Components Academy, and if the Download Files option appears, you can download the example files. For a product to move from one process to another process in process modeling, 6 things are required. The first thing is to have a dynamic component defined as a product. The second thing is that a product requires a flow through processes, so in this example, from feeder to sink. And third, the processes need to be connected to each other via a transport link or several links. So there needs to be a solution between the processes. And fourth, the process needs to push or feed the product forward in its flow. In most cases, this is done using a transport out statement. And fifth, the second process needs to pull or knead the product, which is most commonly done using a transport in statement. And the final thing to make the product move is that the product needs to match what the pulling or kneading process will accept. By default, any product is accepted as long as other requirements are met, such as processes that are part of the flow and there is a solution between them. But if only certain products are accepted to a process, or a product needs to have specific features, then we are talking about product filtering. Product filtering or filters are used to restrict product access to a process during simulation. So they can be used, for example, to create routing decisions, to pull a particular product from a previous process, or to limit processes to only certain types of products. To do this, there are different types of filters. Filters are defined in process routine statements, which are capable of requiring products from the flow, like transport in or transport pattern in, and assembly slots may also have filters defined. In this example layout, we have 4 different product types in 2 groups. In addition, products have both product and component properties, like SKU or stock keeping unit, and component height. Products are randomly created into a buffer from where they are transported to a sink process. As mentioned earlier, by default, any product is accepted, so no filters are used. So in this case, the sink process accepts any product from the buffer. To filter this, a transport in statement can be selected, and from product filter over on the right, using the Add Product Filter button, new filters may be added to the process. The most common filter, called Product Type Filter, limits different product types and flow group members. Once a filter has been created, you may rename it, disable it, or remove it using the Delete Filter button. In this case, both accepted product types and accepted flow groups can be defined. As an example, if I select Box 2, then only green Box 2 products are accepted into this process. In addition, if I add flow group 2 into the accepted flow groups, now both the green box 2 and any member from flow group 2 may enter the process, which in this example is box 4, the yellow box. The second filter is called Product Property Filter. This filter can be used to allow only products with a specific product property and with a property value matching a comparison operator to enter the process. As an example, in products, we have an SKU string value. If we define in a filter that the target property is SKU and the comparison value is 123, only the red box 1 from flow group 1 and the yellow box 4 from flow group 2 can enter, as they match the SKU product property and its value is matching the comparison operator. And if we change the comparison value to 345, then only the blue box 3 from flow group 1 can enter. The third filter is called the expression filter, which allows a user to use any supported expressions. The scope of this filter supports products and their properties, and also process variables where the statement with the filter is located. For example, sync process variables. We could, for example, define that any product can enter where its height is more than the routine variable height in the sync process. So now, any product with a height greater than 400 may enter. The last filter is called specific product. This filter is used if in a process you want to return or pull back a specific product that has left the process. In this example, the product leaves the process to visit a CMM process, but we want to make sure that it returns to a previous process. The product in routine variable contains the product instance, and this same variable can be used in a specific product filter. And now the second transport in statement only accepts that exact product instance back into the process. In addition to individual filters, several different filters can be combined. For example, an expression filter accepting only products where a height greater than 400 could be combined with other filters. If we have a product type filter and define flow group 1 as an accepted flow group, then the yellow box 4 from flow group 2 is ignored, even though its height is greater than 400. And if you change the accepted flow group to flow group 2 and change the operand to OR, then any product with a height greater than 400 or that is a member of flow group 2 is accepted into the process. And this concludes the lesson. Thank you for watching.